Here we have an inequality that's given to us, the solution's given to us in the graphical form. So we need to convert this into an equation inequality. So what we need to determine this is we need to know where the boundary is. We need to know where this line is. So we need to know the equation of that line. Okay, so I need to establish the equation of that line. And so I need to know the slope and the y-intercept. Okay, that would be the easiest way to do it. So I think this y-intercept we can just visually determine as 4. And then I can use my slope triangle to determine my slope. So it looks like I have a rise going left to right. I go 1, 2, 3, 4 down, so minus 4. A run of 1, 2, 3, 4, 5, 6, 7, so plus 7. Okay, so my slope is negative 4 over 7. So my boundary line looks like this. Y equals negative 4 over 7x plus 4. Okay, so we could have done it that way. We can use the intercepts and use the intercepts to generate our linear equation as well. So some people are familiar with doing that, and you can go ahead and do that. Either way you do it, we need an equation for the boundary. Now at this point we need to then establish what the inequality is going to be. Now in the y equals form it makes it much easier because we know in the y equals form if I'm above the line the y should be greater. If I'm below the line the y should be smaller or less than. So in this case y is above, so I'm going to write my inequality as y is greater than, and since it's a solid line we make it equal to negative 4 over 7x plus 4, okay, and that's it. Now if I want to convert this into the general form, I can always just do this, get rid of the denominator, so I get 7y less than or equal to, just make sure that this is a valid solution, less than or equal to 4x plus 28, and then we end up with 4x plus 7y is greater than or equal to 28. Okay, so as we go x and y get bigger, more positive in this direction, we're going to have our solution. Okay, so here we have that same soccer ball problem again, and it says soccer balls cost $30 for game balls, $18 for practice balls, and Jason needs to spend less than $680 on balls for the team. So we need to show the inequalities that fits this problem. So we need to show the relationship of the game balls, the number of game balls, and the number of practice balls, and the cost. So that's our relationship. So we're going to let x equal the number of game balls, and y equal the number of practice balls. Okay, and then our relationship looks like this. 30 times x plus 18 times y, and that's going to be the cost, and we need to keep the cost less than $680. So there represents our inequality. So I can plug that inequality into my graph. Okay, so 30x plus 18y is less than $680. Okay, so I need to zoom out a little bit, but my graph then, when I sketch my graph, okay, I have a graph that looks like this, and because my domain is restricted here, I can't have negative x's and negative y's because I can't have negative game balls and negative practice balls. Theirs represents my inequality, so I need to have the cost be below that line. And again, if you're not sure where if it's above or below, we can always solve for our y, and we can see that the y must be below our boundary line. Okay, so this represents our solution. Our intercepts, we can solve for our intercepts here. It looks like our intercepts are going to be about 30, just above 37. So this is 37 0.77 repeating, and our intercept down here represents 22.66 repeating. So if I buy all game balls, I can buy 22 at maximum. If I buy all practice balls, I can buy 37 at maximum, and I can buy any combination of game and practice balls in this area and keep below my cost of $680. So when I look at this problem here, 17 game balls and 9 practice balls represents a coordinate of 7 and 9. I could test that in my inequality. So test in my inequality, x is 17, y is 9, and that has to be keep less than 680. So this is going to be 510. 18 times 9 is going to be 162. And this is going to be 672, and that is less than 680, so that is perfectly acceptable. So 17 and 9 is near the boundary, okay, but it's still within the boundary area.